Okay, ready when you are.
I'm ready. I can start whenever.
All right.
All right, then. So this is our Google VM, which we'll be using to train the YOLO. We're using YOLO of course to train. So first of all, there is a Google link which includes all the different instructions. Let me just go through that. I'll have to share that screen as well. So just a moment. Okay. So all the instructions should be.
Afreen, we can see all of your screen now.
Wait, really? Wait,
Yeah.
can you see this little black thing coming in?
What thing? Well,
Is there a little?
all your tabs.
You can see my tabs, but can you see? I put something in front of it. Can you see it? It's like the Google VM that was open earlier.
The black. No, we can't see that. So maybe that's what it is. When you share that, it only shares that. But when you share everything else, it's letting you share your entire screen.
Wait, let me just okay, what do you see now?
I see the YOLO training plan.
Oh, I've closed it, so it's not really showing my screen. It's just showing that one tab that's open.
Okay, so
if I have to show the training plan, I'll have to keep switching between screens.
I see. Okay, all right.
You get what I'm saying?
Yeah.
So I guess I'll just briefly go through the training plan, and then I'll just stay in the Google VM. That way I don't need to switch too much.
Okay, that's good. And then maybe you could reference back to the other one, because we all have access to it.
Yeah, I can just talk about the headers. Yeah, but.
And Sharia, are you both able to open this in your Google folder? I think we had it shared, but I can share this link again in the chat box right now.
Yes. Where is it in the Google folder?
I just shared it again in the chat box, so if you click it, it'll take you to it.
Okay.
All right, so when everyone's ready, I'll just briefly go through the Google Doc, and then I'll be on the VM mostly.
Okay.
Oh yeah, okay. Yeah, I was able to get to it. Yeah.
Okay, so is everyone ready?
Yep.
All right, so the YOLO training plan is mostly from, so first I used PG Reddy's repository. He has this whole darknet website which is not the darknet as in the internet using Tor. It's actually, he just named it that, but he uses YOLO for object detection training. So over here, he has his repository on Git. I used his repository for my project, and of course I made changes according to what we needed. The thing is, this guy called Alex copied PG Reddy's repository. He added a few more features, and he has really good instructions on how to train and how to add your own classification to whatever PG Reddy has already done. So I've mostly taken my instructions from him. I can add this link to our Google Docs so you have a reference to where most of these instructions come from. So I'll just put that maybe here. And also PG Reddy's darknet site, it has pretty much a lot of instructions as well. So this is also a good reference material. All right, so those two links. And then from those links, that's where the code comes from. Where we'll be training is on the Google VM. So these are the steps that I took for the project. First, we had to label the images. We had a software called LabelMG. That's also included in Alex's GitHub tutorial. You can see it at the bottom. And we just created bounding boxes for all of our images, which is somewhere in the Google Drive. Then we set up the Google Cloud Deep Learning VM. So to set this up, you can't use GPU from day one. There are some special settings you need to go to. I've mentioned those settings, how to get to that. So it might take 2 or 3 days for Google to get back to you and actually tell you that you can use the GPU and you can set up the deep learning VM. That's the one that I used. And in a bit, I'll show you the deep learning VM. By the way, anyone who sets up a Google account gets $300 free, so you can train and it won't cost that much. And that's about the Google VM. Then let's talk about training. So pretty much these are done on a Linux system. It's actually Debian, the specific flavor of Linux. And these are all the instructions that I've used. Now, as I'm explaining stuff on the Google VM, I'll reference certain parts of the rest of the Google Doc. So it might be a bit confusing, but I'm sure if I talk about page numbers, it'll be easy to navigate. So I'm going to stop sharing my screen and open up the Google VM. All right, I hope you can see the Google VM box.
Yep.
All right, great. So let me start with just explaining how this works. I've connected through the web browser. You can use MOBA Xterm for SSH. It's faster if you use MOBA Xterm. So let's just get to the basic foundations of how you set this up. So first, okay, so I have my tree images here that I downloaded from the Google Drive. I made it as a zip folder, so these are the images that we'll be training. You can easily download stuff by just going to this folder here, and you can choose upload a file and then upload anything from your computer. So that's a straightforward way to do it. Now if I go into my documents, so I have two darknet models that I made. One of them was from Alex and the other was from PG Ready. They both work, but I prefer PG Ready's because it's simpler and cleaner. So it's really up to you which one you want to use. I'll be talking about how I implemented Redmond's version. So that would be darknet 1. By the way, all of this code is available on GitHub as well. I'll share the link on the Google Drive. I had to take out certain parts of the code because it was too large for GitHub. All right. So essentially, okay, so let's go to darknet. Okay. So this is all the files that were provided by PG Ready. And you can notice the predictions.jpg. Whenever you predict, that's basically that's the image which you have to open up to see how your prediction looks like. All right, so I'm going to start from the basics. If you go to your Google Doc, I believe the first step is downloading the repository. So let's go to page 1 or, all right, so in page 1 it says on Linux to download Alex's GitHub one, but you don't have to. You can use PG Ready's, it's up to you. You can just say git clone and do it. So git clone should work on your system, and that downloads his repository for you onto your system. Then after that, you have to write make. But before you write make, you need to set up the make file. Unfortunately, if I've already made the make file, I don't think I can do it again. Or if, no, I have it here. So I'm going to show you a bit of the make file, just to give you a view. Okay. Okay, maybe I'll just read into it. And it's empty. No, this isn't it either. The thing is, on your, after you install the files from GitHub, there is a folder which allows you to, well, rather a file which you can change the settings on it. So since we're using a GPU, you have to make the GPU setting into 1. The thing is, I'm trying to figure out which folder that is. This makefile isn't opening on mine. And once you make it, you can't release. So makefile contains all the commands. It contains a bunch of code and all your settings. Once you write make, you get this darknet which is what's going to train your neural network and everything. So unfortunately, I can't show you how Makefile looks, but Makefile has certain settings that you can change around. So since we have a GPU, we can, it's equal, on the file it says GPU is equal to 0, but you can change it to 1 if you're on Google VM or if you have any GPU setup on your system. So if we go back to the Google Doc, which I'll be referencing, it explains how you set up the whole training. So what we have to do is we take the neural network that's already been trained by PG-Ready, and on top of that, we're training our custom-made objects. So whenever I write down ls over here, it tells me all the files that are right now in my directory. So one of them is darknet53.convolution74. This is the trained weights by PG-Ready. On top of this weight, I'm going to be training my images. So you have to download this. In the Google Doc, it references how to download it. I believe either on the 3rd page, it should be, yeah, it's on the 3rd page. It says download pre-trained weights for convolution layers, and it tells you where to get them. And you need to put it into the build directory. So there's a build directory. You can just go to cd build, and you should be able to put it in and move it in. What I'm going to be talking about is mostly where to put your images and how you do that. So essentially, we're going to be going into the OBJ folder. All right, actually not the OBJ folder, my bad. It's in the data folder. And in the data folder, we have the OBJ folder. So you have to do 2 very important things. The first thing is you need to create an OBJ folder in your data folder, right? And you need to put all your data in here. So you can see I have the trees_test and the trees_train. Now these, I'll just go inside trees_train. These folders will contain your images as well as the bounding boxes that you've pre-labeled already. So you have to load that into this folder. That's right in your data/obj. So now you have your classes in. So I have put that, and now I'm going back. And now in the data folder, we need to have train.txt and test.txt. Let me show you how train.txt looks like. This is train.txt. It's a text file that contains the path. You can see data/obj to my trained images only. How do I do this? There's an easy Linux command to do it. And I believe it's in the Google Doc as well. So let me just scroll down and tell you where you can find it. Okay, so, right. So if you want to train, okay, I can't find the bash command, but there is one. Yeah, I think I did find it. Okay, it's on the first page. It says relevant Linux commands, and it's ls star.txt, and you put it into something called filenames.txt. So essentially what you can do is you can be in your trees_test folder. In my case, it's trees because that's my object. And you can make a list of all of the images you have by using a simple Linux command. You need not write it down by hand. Once you have that, you just need to make sure you put all of the directory, basically all of the images, you need to put down their directory information so that your darknet trainer knows where your images are located. So notice the path of the image is relative to where your darknet, let me just tell you what I mean when I say darknet. I mean this. Your darknet file is. So these are the path of the tree images relative to that. All right, back to data folder. We also have a test.txt, which contains all the paths to the test images. All right, so those two are important txt folders. Then the next two files you need to make are obj.data and obj.name. What are these? Let me explain it to you. So obj.data is simply a file that contains how many classes you're training for. So in my case, I trained for 2 classes, and I have to give the path of where, basically where my train.txt is and my test.txt is. And notice this is the path relative to that darknet file which I was talking about initially, right? So that's the data for the train, the test, and then the names as well. So obj.names is something that you have to create as well. obj.names. And obj.names contains your class names. I'll show you how that's set up as well. But before I go into that, notice the last line is your backup folder. So you already have a backup folder right up here in your, you can say, home directory in a sense. And this is where your weights are going to be stored. So after you train, you're going to get a final weights file, and that's going to be what you're going to use to test your images. All right, let me show you how the obj.names looks like. Okay, so you can see that there aren't any new lines. This is the content, Jelly Palm and Baruti Palm. These are the names of the classes that I trained for. Now, be careful when you label your images using, you have to label them and give them a number. I gave Jelly Palm the number 0 in the labeled images and Baruti Palm the number 1. Make sure you have the order right. If you mix it up, then when it classifies your images, it's probably going to label things wrong. So that's just something to keep in mind. So that's all you have to set up here. It's pretty straightforward. You need to have an obj.names and obj.data, and then you just have to have a test.txt, a train.txt, and finally you're going to have a folder called obj, which contains your images, your test and train images in separate folders. So that's pretty straightforward. You just have to set it up. The only tricky part is getting the test and train.txt right. You need to make sure the paths are correct. So that's pretty much for this part. The next important part is, okay, we need to make changes to our neural network itself. So since we changed how many classes we have, our neural network by default also changes. All the neural network files are stored in CFG. So I'm going to go to CFG. All right, now we're using YOLO version 3/obj.config. I've already tried the tiny as well. Both seem to work. I have separate instructions for how to train on the tiny one, but for now I'll just stress on this one. So this is the one I made, and I made it from this one, this YOLO version 3.config. So this is what's given to you by PGReady, and you need to make your own. So don't change this one. Make a copy of it. There's a simple command. You just say cp YOLO v3, and then you call it maybe foo.cfg, whatever you want to call it. And that's not cfg, you have to say move. And then you can just do whatever you want. But essentially, that's how you create, you just have to make a copy of it. And once you have the copy of it, you have to make certain changes to the YOLO version 3.cfg file that you're going to use for your training. So notice this one's custom made. So after I copied this into YOLO version 3/obj, I made changes to it. So let me just show you how to make changes to your CFG file. So in this case, I'm working with YOLO version 3/obj. So I'm just going to copy that, paste it. So VI is an editor. Since we can't really open anything here, we have to use an editor separately to actually see our files. All right, so if you look at the instructions on the, what's it called? The Google Doc. It says on page, what page is that? It's the second page. So you have to create a YOLO/obj.config file, and it tells you what are the instructions. So it says change line batch to 64, subdivisions to 8, then you have to change max batches. So you have a lot of math that you have to do right now. Essentially what you're doing is, notice that you have, okay, let me go to the beginning of this so you can actually see it. So what I found was setting this up on Ubuntu desktop, it was a lot easier because you can actually open files and stuff on a GUI interface, and then you load everything from that into Debian server. That way you don't need to really deal with all of this bash mostly, but if you're okay with bash, then this shouldn't be too hard. So notice that in the instructions it says to change the batch to 64 and subdivisions to 2. Now I did do that, but I got errors, so I found a solution where they said change the batch to 8 and subdivisions to 2 instead, and that information is also on the Google Doc at about, I would say, where is it? It's not kind of on page 3. It just says, all right, I found a semi-solution. So instead of changing batches to 64 and 8, according to Alex's GitHub, I'm changing it to 8 and 2 because it works better for me that way. All right.
Can I ask a question? What do these numbers represent?
So it represents how many images you're training at once. So batch 64, for example, means 64 at a time. And how many divisions are you making in the image at a time? So I guess the GPU wasn't able to handle 64.
So you had to reduce the number of images that you were going to train at the same time from 64
Exactly.
to 8, and then subdivide it not in 8 but 2.
Yeah.
Now, how did you figure out those numbers? Did you just play around with them, or did you find how did you know that those numbers worked?
Right. So when I encountered this problem, I started Googling things, and people had similar problems when they tried training. And this is what, word for word, one person said. He just found a semi-solution, like it's on the Google Doc, where he reduced the batch to 8 and subdivisions to 2. And he explained why he did it, because he found that that was the best way to actually get the GPU to be all right with such a large number, because the number was too large before. So I believe he had to reduce it. So I just tried to follow his solution, and it ended up working. I'm not 100% sure why it works, but I'm happy it does.
Do you think it's going to be different for different types of images? Because you were training trees versus, let's say, we're training sea turtle tracks or snow leopards or other animals.
So it could be. I would recommend that they first start with, using batch to be 64 and subdivisions to 8, the original number. And if it doesn't work, then to try this.
So when you had it originally set at 64 and 8, what was the error that you received?
So it was hanging up. It wouldn't even start the training. It would just hang up and pause for a really long time.
Got it. Okay. Thanks.
All right. Awesome. All right. So getting back to the changes you have to make. By the way, this is called a Vim editor. So if you you can't backspace and write stuff at the same time. There are special commands. So you could Google that up. But essentially, I just write I to insert things, and once I'm done inserting, I write escape to backspace. So it's a bit of a challenge, but it works. So aside from batch and subdivisions, also we have to change max batches.
Is that in the instructions somewhere?
Yeah, it is.
Okay.
So let me reference that to make it clearer. So it's on page 2, training version 3. It's on, so we talked about batches, subdivisions. It's in the max batches. So it tells you how to calculate what your max batch is going to be. It's how many classes you have times 2,000. It also gives you a little example. And then also line steps. It tells you to be 80% to 90% of whatever your max batch value was. So depending upon how many classes you have, you need to change these values around.
Okay.
All right. And then it tells you on specific lines. These are the YOLO layers in the neural network. We have to make certain changes according to, again, how many classes we have. So for example, here it says change filters. It becomes classes plus 5 times 3. So I had 2 classes, so it's 2 plus 5, which is 7 times 3, 21. So I changed the filters in those 3 YOLO layers to 21. It's a bit at the bottom of the file. So I'll try to find it. It's all the way towards the bottom. So I don't recommend setting it all up on Debian because it's just too much. There are no line numbers, nothing, and it's just tedious.
So
It's by far easier.
yeah, what was the other method that you said you used?
So what I use is I use Oracle VirtualBox, and I installed Ubuntu Desktop. So that has a GUI on it, like Windows, and you can open it with whatever editor you want, and actually, it's a lot easier to make changes to the file.
Is that in your training as well as an alternative?
No, it's not, because I think that someone could do that if they wanted to. It doesn't really say you have to use what I'm using right now. But yeah, I believe, so what line numbers were it? It said it was on line 610, 696. By the way, there are discrepancies in these line numbers because this is from Alex's tutorial, but we're using PG Reddy's neural network, so there might be a few discrepancies. You might not find it exactly on the line that he says it's on, so you had to explore a bit. All right, so that's line 610. So at around 600 somewhere, we should find filters and classes that we had to change. Oh, and I just figured it out. There are line numbers at the bottom, so I guess that saves some time. Right, so this was the first YOLO layer, and we can see that filters was something else initially. It was like 256, and I changed it to 21 because that's how much we needed at. And classes was some other number, and I changed it to 2 because I only have 2 classes. So these changes need to be made on all the 3 layers, and you can find them on these lines 610, 696, and 783, more or less. It's on the Google Doc. So we changed both classes and filters. And that's about it. That's what you have to do for the config file. You're not pretty much done with that. Then if you scroll down on the Google Doc, it talks about your obj.names and obj.data. I already explained what you have to do for each of them. So obj.names was just the names of your classes. Obj.data was just the information file that contained how many classes you have, what you're training, your validation or test. I called it as test. Over here it says valid. I'll just change it back to test. And the name, where are your names located, which is obj.names, and the backup where your neural network weights are going to be stored. So all of these are, of course, in the data folder. We already went through that. And if you continue scrolling down, it talks about where you need to put your JPEG images. That's, again, in your data/obj directory. Now notice in Alex's it says build 64 darknet, and that's kind of confusing, but if you use PG Reddy's, it's just data/obj. So I might just want to make a little note about that on the Google Doc. All right, so that's all set up. We created the text files as well. Finally, we get on to the training. So this should be about at the bottom of the 3rd page of the Google Doc. It explains how to train, so I'm just going to exit Vim. You just do :WQ. And right now, we're going to get out of the config folder. we're back on in the main directory where we do our training. So I'm just going to show you that inside my backup file, folder what I have right now, I have a lot of weights because I've been training things. So I've been training with the YOLO version 3 Tiny and the YOLO version 3 OBJ. And that's why I have files in here. When you start, you won't have anything. It'll be empty. So let me just get out of here. And let me try to train from scratch so I can show you how you would have to train. So if you go to the Google Doc, it actually has the exact commands you need for training. So it's the first black highlighted piece of text. It says YOLO darknet detector train data/obj.data, and then it tells you the configuration file you're using. So that was for Tiny, but you can change it according to what configuration file you're using. So I would use YOLO version 3/obj, and then you have to talk about your configuration. Yeah, so that, and then what neural network you're using. The trains, the weights. So let me just copy paste it so you get an idea of what we're doing exactly. All right, so I'm just going to paste that. So I'm going to make a few changes. So we have data/obj.data. The configuration file is named differently now. I believe it's called YOLO version 3. So whatever you edited, that's what you're going to use now. And that's going to go right over here. Okay. Oh no. Okay, wait, I think I copied something wrong. Alright, so this goes here. And then this thing right over here needs to get backspace. Okay, so that's your configuration file. And this is the weights you're using so far. So if you've already trained and you want to train on top of some weights because you want more accuracy maybe, then instead of saying darknet 53, this thing here that you downloaded before, you would just choose one of these maybe. Let's say I trained till 700 and I want to train more, like till 1000, then I would just take this, copy, paste it, and replace it instead of this. So now if I press enter, it should work. So notice it says loading weights from the weights that we just downloaded. And now it's starting to train. So you can see the numbers here denote, like, this is the first cycle, the second cycle, the third cycle going through the network. And it actually tells you, kind of gives you a gist of what's happening. So I believe over here, it tells you the error. So this has really high error. And we want this to be as low as possible. When I trained, I think it came down to 7 or 6 from 758. So that's the training. It's going to keep going on. I think YOLO recommends that you travel for about 2,000 times for each class, or about that number, or 1,000 times for each class. I trained for 700, and it worked pretty much. So it's going to keep training. You might need to keep it for about 8 hours or so, depending upon your needs, or when you see that the error has reduced. And once this has reduced, you're good. And it's mentioned in the Google Doc as well when you should stop training, or when they recommend you stop training. Let me just go to the Google Doc just to reference it. It might not be mentioned here, so you would have to go to Alex's link at the top, and down he explains when you should stop training. He has a graph and everything, and he explains when you're overfitting, when you're underfitting. But essentially he says that when your error or average loss comes down to 0.06, then you're good. But sometimes you can't make it go down for really difficult data sets. So that's also one point there. But essentially it's going to keep training. Now let's pretend like we're done training. I'm just going to end the training forcefully, but you shouldn't do that. And I'm going to pretend like it finished training. And if I go to my backup folder, that's where everything gets stored. And I have a bunch of weights now. So I see the highest number of weights, which is 900. And the final weight is like the highest actually, but I sometimes just prefer to use 900 or the particular numbers. Sometimes you might find that 700 works better than 900 because maybe you overfit. So try to use all the weights when you're testing. All right, so let's try to test an image just for fun. So in my Google Doc, I have a list of images that are my testing images. You don't want to test with images you trained with. That wouldn't work very well. And let me just go there. So if I scroll down on the Google Doc, there's a command for detecting. So it says darknet detect. Should be somewhere here. Train, detect. Okay. Let me find it. I found it. obj.data, yeah. So all right, so this is the command that you would use, but let me just get it right. So it depends on your system, of course. So it's detect. So now you're testing the images, right? So you have data/obj.data. You have your configuration file. So the configuration file we used earlier, if I'm not wrong, was YOLO version 3/obj. And then the backup is essentially what network are you using, what weights folder or file rather are you using to test the image. So in this case, I'm going to choose YOLO version 3/700. Okay, so let's just try 700. Oh, I'm in the wrong directory. You have to be in your root directory where you have, you know, your darknet, where you install the package, or else it won't work because it's using darknet, the darknet file. So this should work. And now we need to put in an image path. So I have a bunch of image paths that I have for my for the trees. So these are the testing, you can say paths. You can choose whichever one you want, whichever you have, and just put in the image path, and then you do it, and it predicts it for you. Unfortunately, I can't show you the image results because I can only share one window at a time, but you can quit this, get out of here, and in your predictions.jpg, if you just download it, and you can download it really easily, you just need to go here and say download file, and then put down the whole path, starting from the home path. You can download your predictions.jpg and have a look at how it worked out. So that's how it would work over there. And then you can actually see bounding boxes on your whatever you trained for. Obviously, if you train for longer, these values should go up. But essentially, that's how you train on YOLO. And does anyone have any questions?
Yeah, Afreen, can you actually show an example of one of the bounding boxes, the photos, the images that you sent?
I'm not sure if I can screen share it, but let me try to do something. Let me stop sharing the VM
Okay.
and let me share the maybe.
If not, I can go back to one of the older ones that you sent me and just share my screen just so they can see what it looks like.
Well, what I would have to do is put the image in the Google Doc, so I don't know how helpful that would be.
Yeah, hold on. Let's see. Let's see if I can find it. Oh yeah, that's a good idea. Yeah, just put like one of the images in there. Yeah.
Okay, I'm on it. Let me get the images as well as the info. Okay. So I'll put it for both the classes that I trained. On 1, on 2, okay. Okay. Can you guys see my screen?
Yeah.
All right. So when I tested it for a different image, I think these are scattered a bit. Okay. So this was how the bounding boxes looked for the jelly palm image. And this is the result that came along with it on the screen. So we can see the accuracy values. And this was for the second class, Baruti palms. And the accuracy values, I'll just put them in a minute. These were the accuracy values for them.
So
that's pretty much it.
Pretty close.
Mm-hmm.
Yeah, that we
I
thought
think
this
a
one
bit
was
more.
going to be impossible.
Oh, wow.
Yeah, that's pretty impressive for the Baruti poem because it's so like nestled within a bunch of other trees.
I mean, it's kind of tricky to see it with the human eye, but the computer was able to differentiate it pretty well. It actually missed a few, I think.
Yeah, but I mean, even getting that much, I think is just remarkable to be able to know that, you know, in this area you'll find some of these Baruti palms. That's
Exactly.
yeah, because I think for the project they wanted just like clusters, and those clusters could have included other trees, but with this, it seems like, you know, it's trying to accurately locate the actual individual trees finds, which I think is really hard because you've got the color and everything's like mushed in together.
Yeah, absolutely. For the jelly palm, it was quite simple and straightforward.
Yeah.
Because it's like in a desert landscape.
Yeah.
But for the Baruti palm, certainly, definitely was quite hard. The next step would be if both the trees are in the same environment, would it be able to differentiate them?
Yeah, that would be interesting to see, but I think that was part of what we were talking about, that we might not run into that issue because they do grow in totally different environments. So we wouldn't necessarily have a clash of these two palms in the same area.
Yeah, so I guess that's pretty good for this project, but we have to see for the others how it works.
Yeah, yeah, definitely. I mean, for this, I mean, that's really impressive. And you said it took you did 8 hours of training for this?
Well, that was on the previous one using Alex's GitHub, but on PG Ready, that only trained for like 3-4 hours.
Really? Wow.
Yeah.
So, and was that for both of the trees or Baruti palm? Which?
It was for both of them together.
3 hours for both of them together?
Yeah, I was pretty surprised.
And how many images? Yeah, and how many images did you have?
I had a few images, like only 30, but each image had many trees in it. So I think the Baruti palm came to about 100.
Yeah, but I mean, even that is not a whole lot, right? If you think about it, because everybody's always talking about how much data you need to be able to do the detection, but with 100 trees that are labeled, 3 hours of training, that's really good.
Yeah, it could also be that training trees is an easier data set, perhaps compared to maybe other possibilities out there.
Yeah, I'd love for you to do this for the turtle tracks, because I feel like the turtle tracks would be even easier than the tree species. Because
Yeah, it
they're
might
pretty
be. If
distinct.
you could share the images with me
Yeah.
anytime, and I could do it.
Yeah, just as a test to see if you kind of get the same results that we got with the team before, because I feel like they might not have, maybe their training and testing was on the same exact images. So this way, if you retrain it with a fewer images and test it on that entire video that we have to see if it actually works. You've seen that video, right? With the tree, the sea turtles?
Yeah, you showed it to us. It was pretty cool. It was, I think, on our first day you showed it to us.
Yeah, it was really, really cool. So I feel like, I think because you're able to identify, especially this one, the Baruti, because it's nestled in, being able to detect the tracks should be much easier.
Hopefully.
Yeah, I'll send you the link for that folder and images that we have. I think there's some images that are already labeled, and we might even already have them in the YOLO format that you need. So it might even be faster if you did that, if you use that to do the training.
Yeah, I would like that. If it's labeled, that's great.
Yeah. All right. Well, maybe we can ask the others if they have questions.
All right, everyone, how'd it go? Did you understand anything? It was complicated.
It was really interesting, but I'd like to see I'd like the screen recording so I can like go through it like step by step, just because it's a little fast. But it made sense, and I just need like more practice with it. But it was really cool to like learn.
That's good to hear.
Yeah, definitely. I want to congratulate you because you've gotten like really good results with it, and I know it's not just like easy. Just like in the training, it seems pretty straightforward, but I'm pretty sure you have to go through a lot to like actually get to good results because that's how it goes with training and testing. So yeah, it's pretty cool, and I think as well going through the screen recording, it's like a way to actually see it and like try it ourselves.
Mm-hmm. So if
that
you
was
guys have questions later, you could always email me. I have my email as Afreen at Kashmir World Foundation. So since I've already done it, I could probably help you out.
Yeah.
Thank you.
This was really, really good, but my programming skills are like probably kindergarten level. So from my perspective, it was like, oh my gosh, this is so hard. Like everything that you showed me, I'm like, I don't know if I can do it, because I don't do any kind of programming at all. However, I do feel like if you go through that first part of setting it up, it could be a lot easier than I think most people think deep learning is. But I think that setup part and just configuring it right for your project, which was the key thing that you had to mention, that you can't just copy and paste somebody else's deep learning neural network. You probably have to do some kind of modifications to make sure that it works for your project. And I think for that, it's hard to, like, I think personally for me, it'd be like, well, where do I even start? But one of the things you mentioned was, with that batch thing, it immediately kind of just hung up and wouldn't even move forward. So you knew, well, something needs to be different about that. And yeah, I think just from that perspective, I think there are probably a lot of other little changes with the setup that I think will vary from one project to another, and we won't really know that until we start working with it. And that's why I think it'd be really interesting if you had a chance to work on the sea turtle one as well as the snow leopard one, because since you've done the tree,
Yeah.
you can easily see the difference in what you had to do from identifying like a tree to an animal to just the tracks on the sand. And it'll be kind of really interesting to get that. Where are those changes? Where do they need to be? Ooh.
So I could work on those. Just send me the data sets and
Okay. Yeah.
I'll let you know.
Definitely I'll definitely do that. And it looks like Georgie finally joined, and Mandeep also joined as well. But we are actually done, guys, on our training here. But we'll have the video. I'll have that available for everybody to watch, as well as the link that Afreen created for her training data set. I've already shared that with everyone as well. So why don't you guys go through that and then try to see if you can make it work based on that, and then we can move forward with trying it out on the other project. Any other questions?
No.
All right, cool. Well, thank you so much, Afreen, for your time. This was really, really, really helpful, I think, just to see the entire process of it. And I think we do have a recorded video that somebody else did on how to do labeling of the images for training. Georgie, do you think you can send that information to me, and then I'll make sure to share it with the rest of the team? Yes. Hello? I don't know. I think he's on mute. Okay.
Yeah.
Never mind. Okay. All right. Well, thanks so much, Afreen and Emily and Sharia, for being here for training. Yeah. Georgie, what?
Yeah, it's in the drive. It's in the Snow Leopard AI portal. It's under labeling instructions.
Okay,
it's right there.
Okay, labeling. Okay, let me share that with everybody's, and I'll also link it to. I'll link it to your document as well, Afreen. So then that way, it will be.
All the information's there, like in one place.
Exactly. Let me go there because I know Albert did. He's done a thorough instructions for it and a video. So that's pretty awesome. Okay, that'll be great.
Thank you, Afreen.
Yeah, thank you so much.
Thank you so much. All right, you guys have a good evening.
You too.
All right, goodbye.
Bye.
Bye.